Hello GATE aspirants, welcome to part 11 of GATE Mathematical Physics series. Question 1. Which one of the following is a solution of d2ux upon dtx square is equal to k square u of x for k real? So this is the equation. We have d square is equal to k square. So d is equal to plus or minus k. So the solutions are e raised to kx or e raised to minus kx. So option A is correct. Next question. A real invertible 3 cross 3 matrix has eigenvalues lambda I and corresponding eigenvectors. Which one of the following is correct? Now eigenvalue equation is m operated on ei will give you lambda I ei. Now let us multiply on both sides by m inverse. So m inverse m into ei is equal to lambda I is a scalar, m inverse ei. So this will be identity matrix. So identity matrix ei is equal to lambda I m inverse ei. So this is simply identity matrix. We can take this lambda on the left hand side. So 1 upon lambda I ei is equal to m inverse of ei. So we will get option B is correct. See, first option is not correct because lambda I should be numerator. Here also it is not correct. And eigenvalues and eigenvalues of m and m inverse are related by this equation. Next question. For a complex variable z and a counter c, mod of z equal to 1 taken in clockwise sense. So this is the counter. This value is 1, 0. The counterclockwise direction, the value of this. So we have 1 upon 2 pi I integral of z minus 2z plus 3z square dz. This is equal to, we have 1 upon 2 pi I and value of this integral is 2 pi I into residue. Now residue is coefficient of 1 by z and coefficient of 1 by z is here. So this 2 pi and 2 pi will cancel and coefficient of 1 by z. And here it is minus of 2. So answer will be minus of 2. Next question. The product of eigenvalues is. Now product of eigenvalues lambda I is equal to determinant of m. So determinant is, here we have 1 into 0 minus 1. So that is minus 1. So option A is correct. Next question. Let E1, E2, E3, let S be this set. Let R3 denote the three-dimensional real vector space. Which one of the following is correct? First is S is an orthonormal set. Orthonormal means all vectors should be normalized. Now let us find out magnitude of E3. So E3, magnitude of E3 will be square root of 1 square plus 1 square plus 1 square. So that is square root of 3, which is not equal to 1. So it is not normalized. So that means option A is wrong. Option B, S is linearly dependent set. So let us find out value of this determinant. That is 1, 0, 0, E1, then E2, 1, 1, 0, then 1, 1, 1, E3. This is equal to 1 into 1 minus 1 into, this will be 0, plus 1 into, this will be 0. That is 1, which is not equal to 0. So it is linearly independent. Now next point is, so it is linearly independent, so it can form basis for R3. So option C is correct. Then option D is this outer product. So let us find out value of it. So we have first E1, outer product with E1. So this will be equal to 1, 0, 0 and then we have 1, 0, 0. So this will be equal to 1, 0, 0, 0, 0, 0, 0, 0. Next is E2. E2 is 1, 1, 0 and then we have 1, 1, 0. So this will be 1, 1, 1, 0 like this. For E3, we have 1, 1, 1 multiplied by 1, 1, 1. Okay. So this will be equal to this matrix. And if we add all these matrices, So summation from 1 to 3 ei ei. So if we add, so first will be 3, then here 2 2 2 and then 1 1 1. So this is not equal to identity matrix. So option D is wrong. Only option C is correct. Next question. Which one of the following matrices does not represent a proper rotation in a plane? So it will represent proper rotation if determinant of M is equal to 1. So that we have to find. Now for the first case, it will be sine square theta plus cos square theta. So that is equal to, so this is sine theta into sine theta. So sine square theta plus cos square theta. So this is equal to 1. Next we have cos square theta. So this is equal to cos square theta plus sine square theta equal to 1. Here we have sine square theta plus cos square theta. This is equal to 1. Then we have sine square theta plus cos square theta equal to 1. And here we will have minus of sine square theta minus plus, that is cos square theta. So in first two cases we are getting 1, but in the last option we will not get proper rotation. Next question. Let u mu denote the forward velocity of a relativistic particle whose square is equal to 1. If epsilon is the Levi-Civita tensor, then the value of this is. Now we have Levi-Civita tensor, this is, and it is totally antisymmetric tensor. Antisymmetric tensor means if any of the two indices are swapped, then it changes its sign, and if any of the two indices here are equal, then it vanishes. So it is antisymmetric. And this forward velocity vector is symmetric. So now this cannot be matched with the antisymmetric structure of Levi-Civita tensor. So this multiplication has to be equal to 0. And answer in the answer key is 0 to 0. Next question. If x is equal to summation over ak sin kx for this range, then value of a2 is. Now let us find out integration from minus pi to pi x into, and I will multiply by sin kx on both sides. So this will be sin kx dx is equal to, this ak we can take common, and we have integration from minus pi to pi, and sin kx into sin square x is sin square kx dx. Here we have complete summation and all terms will be there, but only that one term will survive for which this k are same. So this k and this k, it has to be same, only then it will survive. Because if we are considering integration of sin mx into sin nx, then it is going to be 0 if m is not equal to n. That's why only this term will survive. Now let us do this integration. So we have u into integration of v dx. So integration of sin kx is minus of cos kx upon k, then minus of cos kx, so which is sin kx upon k square, and minus minus will become plus. Minus pi to pi is equal to, we have ak here, then sin square kx can be written as 1 minus cos 2kx. So upon 2 is there, and integration of 1 is x, and integration of cos 2kx is sin 2kx. So this will be sin 2kx by 2k, and is going from minus infinity to plus infinity. Now here it is given that we have to find its value for 2. So k should be equal to 2. So let us substitute value of k. So this will be x minus, so it is multiplication of it. So minus of x cos of 2x upon 2 plus sin of 2x upon 2 square is 4 minus pi to pi is equal to a2 by 2 x of plus sin 2k, that is 4x upon 4 minus pi to pi. So this is equal to, first is minus pi, then cos of 2 pi, cos of 2 pi is 1. This will be minus pi by 2 plus sin 2 pi is 0, then minus of minus pi. Now cos of 2 pi is 1, so this will be x by 2. So minus of pi by 2 here. And sin 2 minus pi, it also will be 0. Then we have a2 by 2. Here we have this term, sin term will be 0. This term will be 0. So pi minus pi by pi, so that will be 2 pi. So this is minus pi is equal to a2 into 2 and 2 will cancel out into pi. So a2 is equal to minus 1. So answer is minus 1. And answer given in the answer range is minus 1 to minus 1. Next question. Let fn of x is 0 and 0 in this range. The value of limit n tends to infinity, integration fn x sin x dx is. So limit n tending to infinity, minus infinity to infinity, fn of x sin x dx is. So this is equal to limit n tending to infinity. So this is it will be having non-zero value in this region only. So minus 1 by 2n to 1 by 2n, and its value is n into sin x dx. So we have limit n tending to infinity, n is constant and sin kx is minus of cos x, and limit is minus 1 by 2n, 1 by 2n. So this is equal to limit n tending to infinity, then minus n cos of 1 by 2n minus cos of minus of 1 by 2n, but it will be 1 by 2n only because cos of minus theta is theta, so this will be 0. So answer is 0, and answer given in the answer key is 0 to 0. So these were all the questions from GATE 2020 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.